Dear students, my name is Prashant. I am from Pragati the school. This class is designed for online classes for 10th standard students of Cbse and Karnataka SSLC stream. Today we are going to see the chapter in physics which is source of energy. Energy is the capacity of a body to do work. What is energy? Energy is the capacity of a body to do work. We have seen different forms of energy, isn't it? Kinetic energy, potential energy, solar energy, heat energy, electrical energy, muscular energy. I have inserted the GIF images here. You can see kinetic energy. When the body is in motion, it is a kinetic energy. When the body is stationary at particular height, then we say it has got potential energy. Then coming to the solar energy here, we are seeing the solar energy here. Sun rays will fall onto the solar panel, then the electricity is generated and it can be used for house appliances like light, fan, fridge. Then again it can be given back to the grid. Then come to the electrical energy. You can see here battery is a stored source of electrical energy. When it is switched on, the electrons will flow and the bulb will glow. And you can see here the heat energy. Because of the heated steam, the steam entering inside a piston, it moves an engine, the railway engine. So this is an example of heat energy. You can see here the action. Then the muscular energy here, the muscle energy is required to lift the weight. That means to do the work. The lifting of the weight is nothing but doing the work. So we need energy. Here what energy is being used? The muscle energy or the muscular energy. Any source of energy we use to do work is consumed and cannot be used again. Law of conservation of energy. One form of energy can be converted to another form of energy. Law of conservation of energy says the energy can neither be created nor destroyed, but it can be converted from one form of energy to the other form of energy. What are the different sources of energy? Where do we get the sources of energy? We can see the diesel is a source of energy, electricity is a source of energy, muscles, the muscular power what we are using is a muscular energy, electrical energy for running various appliances, then chemical energy for cooking food or running a vehicle. You can see different time. See here the train is going. What energy is used? You can see the electrical lines on the top. So electrical energy is used in movement of the train from one place to the other, or the diesel is used. The diesel is a source of energy. Diesel is used in a diesel engine train to move the train from one place to the other. And you can see here the electrical energy to light the lamp at the night time, and we are using here the muscular energy. Why? Because we are riding a cycle. The muscles energy is required to ride a cycle. And here you can see the cooking has been done here. We are using a chemical energy for it, and we can see here what is it, a car which is running on a diesel or a petrol. Diesel or a petrol is nothing but a source of energy, that is nothing but a chemical energy. The chemical energy is nothing but diesel, petrol, kerosene, turpentine, everything is petroleum products, so all those are chemical based, so that's why it is called as a chemical energy. And here a muscular energy is required to lift the dumbbells, and here the chemical is used, sulfuric acid is used for generating electricity. We need to know how to we select the source needed for obtaining the energy in its usable form. Selection of fuel. How to select the fuel, whether to use electricity or petrol or diesel or gas, natural gas. How do we select it? It depends on how much heat does it release on burning. It depends on the amount of calories it is going to release. Okay, and does it produce a lot of smoke or no? Is it easily available or no? Everything, all the three factors should satisfy. Then only it should be very cheap to use the fuel. If it is very costly, if they say the petrol or the diesel, it is 2000 rupees per liter. Are we going to buy petrol or diesel? No. If we say it is 100 rupees, 80 rupees, then we can afford it. If it is 2000 rupees, we cannot afford. We could then say that a good source of energy would be one which would be a large amount of work, which would do a large amount of work per unit volume or mass. It should do a lot of work. It should be easily accessible. That means we should get it. Where do we get petrol, diesel, and the gas? We get from petrol bunk. See here, the petrol stations. It is easily available. Be easy to store and transportation. Okay, for transportation it should be very easy. See here, Shell petrol is being moved from one place to other place. From the factory, the processing factory, it will come to the station and it is going to unload the petrol or diesel. It should be very easy for transportation. Perhaps most importantly, it should be economical. That's what I said. If it is 100 rupees, we can buy it. If it is 2000 rupees per liter, we cannot afford it. So based on these factors, we can select a good fuel. Then coming to the conventional sources of energy. What is conventional source of energy? That means we are using it for a long time. We have been using it for a long time. Example, coal, then petrol, diesel, kerosene, natural gas, everything we have been using since from long time. So those are called as conventional sources of energy. Where do we get conventional sources? We get from fossil fuels. What are fossil fuels? Fossil means which is deeply buried in the earth crust. That means inside the earth it will be buried from soil. What will happen if a wood is buried deep inside the earth? After millions of years, that the fossil, it becomes fossil. The wood would have turned into a thick liquid that is nothing but crude oil. From that we can get petrol, diesel, kerosene, turpentine, petroleum jelly, everything we can get it. Fuels were formed, that fossil fuels were formed over millions of years ago and there are only limited reserves. That means conventional sources of energy is a limited energy. It is already stored inside the earth. Once we use it, consume everything, it becomes empty and zero. So that's why it is called as conventional sources of energy. The fossil fuels are non-renewable, which means it will perish sooner. It becomes empty. Hence, renewable energy sources are considered. You can see here the coal is here, okay, the fossil fuels, and here the coal mining is happening, and here you can see the processing industry where petrol, diesel, everything is being processed here at the process industries. Then these are the thermal power plants where the coal is used to boil the water and get the steam to run the turbines. And here is the petrol bunk where we get petrol, diesel, and different oils here, right? And this is the cooking gas, liquefiable petroleum gas, LPG. So everything is non-renewable sources. The non-renewable sources are conventional sources. Let us see the disadvantages of fossil fuel. What are the disadvantages? It is going to harm our environment very badly. The oxides of carbon, nitrogen, and sulfur that are released on burning fossil fuel are called acidic oxides. That means acidic oxides are formed because of burning and it affects the environment. Pollution. These lead to acid rain which affects our water and soil resources and also the plants. In addition to the problem of air pollution, recall the greenhouse effect of gases like carbon dioxide. Carbon dioxide is released enormously, which will affect the greenhouse. Okay, and if you see this chart here, which is the conventional energy we are going to use? Coal, petroleum and natural gas, hydro water power plant, nuclear power plant, wind energy. See, out of this, coal is the highest percentage. Coal is the highest percentage. What is coal? Coal is a fossil fuel. Coal is a fossil fuel, and it is a conventional sources of energy which is going to perish, which will get empty sooner. See, so much it has been used as a source, and we create acidic oxides, acid rain, air pollution, and it will affect the greenhouse by using coal, which is very dangerous. Besides being used directly for various purposes in gas stoves and vehicles, do you know fossil fuels are the major fuels used for generating electricity? Just now we saw coal. Coal has been used even today at a higher percentage to generate electricity. See, the steam energy is converted into mechanical energy. How the steam is generated? The steam is generated by boiling the water. How do we boil the water? By using coal, right? By using this conventional source, by using this perishable source. Okay, by using this, we boil the water, and the water is converted into steam, and the steam runs the turbine, and the turbine is connected to a dynamo, which is a generator, and it generates the electricity. You can see a small model is given here. A pressure cooker you can take, and you can put some water here, and you can start boiling it. Keep it on the stove. What will happen? The temperature increases, it boils the water, and the steam comes out. Put a pipe here and hold it in a hand. The steam comes out at a very high pressure, and if you keep a turbine, the turbine is going to rotate, and the electricity is generated. Come to the thermal power plant. Thermal power plant. See, here is a thermal power plant. Such a big, huge, big. See, cooling towers. Then the generation towers here, chimneys, building, everything you can see. It is a very, very, very huge. It might be in 100 acres or 200 acres plot. Thermal power plants are huge power plants which consumes lot of area. Heat energy which is converted into electrical energy. What is thermal power plant? That means in thermal power plant, the heat energy is converted into electrical energy. So here, large amount of fossil fuels are burnt every day in power station. Which are fossil fuels here? The coal. Coal is burnt every day in power station to boil the water. You can see here, pulverized coal is being used, and air is given. What will happen? This will burn, and the heat is generated, and that heat is given to a boiler. In the boiler, what will happen? What will happen? The water is coming here, and see, you can just see here the blue color is turning into white and red. What is that? The water is getting converted into steam, very high pressure steam, and this steam is comes here, and it is blown onto the turbine. What will happen to the turbine? The turbine will start rotating at a very high speed. It is connected to a generator. You can see a link rod is being here. Once the steam turbine rotates, the generator also rotates, thus the electricity is generated. You can see here the steam is coming and hitting the turbine. The turbine in turn rotates the generator where electricity is produced. You can see a lot of electricity is being transported from one place to other place. This is a power grid. Okay, see, large amount of fossil fuels are burned every day in power stations to heat up water to produce steam, which further runs the turbine to generate electricity. Just now we have seen here, right? The same thing. The transmission of electrical energy is more efficient than transporting coal or petroleum over the same distance. We can use the wires. See, the wires. We can use the wires to transport electricity from one region to the other region, and it is very easy and cheap. Therefore, many thermal power plants are set up near coal or oil fields. Why coal or oil? Both are non-renewable, both are non-renewable energy sources, that is conventional energy sources, and it should be very near to use for boiling the water. Power plants. That means the potential energy is converted into kinetic energy. You can see here the big dam, beautiful dam is constructed, and water is stored here. That is a water reservoir, and the little amount of water is left to flow. So you can see here the reservoir is here, and water is stored here, and here they are going to leave small amount of water where with lot of pressure it comes, and generator is, the turbine will be kept here, and it rotates the turbine. In turn, it turns the generator, producing the electricity. You can see here the animation here. See, the water is flowing here, and this is a turbine here. The turbine starts rotating. What happens to the turbine? It rotates, and in turn it rotates the generator. Once the generator rotates, the power is produced. See, this power is given to power grid, where it is transferred to your respective houses and industries. Clear? Since the water in the reservoir would be refilled each time it rains, hydropower is a renewable source of energy. That's why it is called as renewable sources. Hydropower plant is renewable. How? Because once the water gets empty in the reservoir, what will happen in the rainy days? Again, it is going to get filled. That's why it is called as renewable sources. That is why it is called as renewable sources. That means non-conventional energy source. You can see the working of a biogas plant. Biogas is also called as gobar gas. Biogas, other name for biogas is gobar gas. You can see here the plant. See, there are a lot of houses, one, two, three, four, lot of houses are there. And you can see here is a place where we can put the cow dung. The excretion of the cow is been put along with the water is mixed nicely. It is made in the form of a slurry, and we have to pour it here. And what happens? It comes here in a septic tank. This is a septic tank, and it comes and stays here for a period of time. What happens? It starts decaying. Once the decaying happens, what happens? The gas is liberated. The methane gas is liberated. You can see the white smoke which is coming. That is the methane gas, which is used for cooking. See here, the pipeline is given to house. Okay, and we can connect the pipeline to all the houses, and we can use this gas for cooking. So that is the use of gobar gas. Clear? How the uh, gas is created inside? Because of microorganisms, bacteria. See, the anaerobic microorganisms that do not require oxygen decompose or break down complex compounds of the cow dung slurry. Once the slurry is poured from here, it comes here in the septic tank, or it is also called as a digester. Here what happens? A microorganism, the bacteria, which does not require the oxygen, it doesn't require oxygen to live. So those organisms, those bacteria will make the cow dung slurry to decompose and to generate the gas. Okay, so that's how the methane gas is produced. Along with the methane gases, carbon dioxide, little percentage, hydrogen and hydrogen sulfide gases are also produced in very small quantity. But you can see here, biogas is an excellent fuel, as it contains up to 75% will be methane. So it is very good to use in domestic. You can see the same thing I've explained here. See, the cow is here, cow dung, the excretion will come and fall here. Directly it will not come, but you have to mix with water. We have to make it as a slurry. That means mix the cow dung nicely with water. What it will become? It will become like a paste. That is called a slurry. That we have to pour it. See, over a period of time, the gases, these are bubbles. The white thing what you're seeing is a bubble. So that comes on the top, and it is collected here in the tank, and it is used for cooking in domestic purpose. And coming to the wind energy, have you seen this anywhere? Anyone who has not seen, I think everyone might have seen this is called as a windmill. What is this called? This is called as windmill. Okay, it is uses wind energy. The air blows over the wings and wings start rotating. You can see here the wings, the air is coming here, and what happens to the wings? The wings will rotate. The wings is connected to a rod, and rod connects, rod rotates, and this rod is connected to generator. Okay, the gearbox is given here to increase the speed of the generator. Okay, because you are seeing here it is rotating very slowly. To increase the speed of the generator, what you have to do, we have to go for a gearbox. What is the function of gearbox? The function of the gearbox is to increase the speed, to increase the speed. So here the generator rotates and it stores the energy and it gives to the transformer and it goes to the grid. That means it comes to our house. See, the wind is coming here, it rotates the generator, and generator produces electricity. Very, very simple. Okay, and what is the principle here? The wind energy is converted to electrical energy, that we know. What should be the wind speed? The wind speed should be also be higher than 15 kilometer per hour. This is very, very important. You should know 15 kilometer per hour. Okay, to maintain the required speed of the generator or the turbine. To generate electricity, the rotation motion of the windmill is used to turn the turbine of the electrical generator. Just now I've explained, no, the same thing is given here. If number of windmills are present, that is called as a wind energy farm. Wind energy farm. Okay, if so many are there, only single windmill is here, it is not called as a farm. If more than 20-30 windmills similar to this are present in one area, that is called as wind energy farm. See, this is a wind energy farm. See how many are there? There are more than 200 thousands. We don't know. All area is covered. Okay, so many windmills are covered. Why? Because the wind flow, which is 15 kilometers per hour, the wind flow will be more at these kind of regions. Establishment of wind energy farms requires large area of land. Obviously, you can see here so much kilometers, hectares of land is required for 1 megawatt generator. If you want to use 1 megawatt, that means 1 into 10 to the power of 6. Mega means 6, kilo means 10 to the power of 3. So 1 megawatt generator, the farm needs about 2 hectares of land. 2 hectare is required to generate 1 megawatt. The initial cost of establishment of the farm is quite high. It is very costly to install. Okay, and it also requires high level of maintenance. It requires high level of maintenance because it is a very huge thing and it is at a very high position. So because of rainy season, storm, cyclone, summer, everything, it gets corrupted. So daily it has to be maintained. So the cost is more. Now we'll see the non-conventional sources of energy. First we'll go for solar energy. In solar energy we'll go for a solar cooker. Have you seen the solar cooker? It is like a cooker. See, cook pot. You put rice or sambar or something and keep it here. See what will happen? Inside it will be there will be a black body. That means inside the box it will be coated with black paint. Why? Because black body absorbs more heat. And you can see here the blue color thing, that is the glass. You can see here this is a glassy or plastic cover. That means you should not allow the air, warm air inside to escape out. Okay, and we are going to open it and keep it in this position so that whatever the sunrise is coming and falling here, it again reflects back to the cooker inside the chamber. Okay, and the chamber, you can see here the sun is here and it's coming, the reflector is here. Once it comes again, it reflects back the heat into the chamber. Heat will not escape and the temperature will be more than 100 degrees centigrade, and the rice will cook, get cooked very easily. And here also you can see same thing, the sun is here, it is a curved parabolic reflector. That means the mirrors are arranged in such a way that it is in the form of a parabola, and you can see here all the reflected ray will concentrate at a focal point. At focal point we can keep the cook pot here. What happens? It gets heated up and inside the food will get cooked very easily. And this is a, and similar, this one you can see, this is a concave reflector similar to parabolic reflector. All the rays which is falling on the concave will concentrate at the, reflect back at the focal point where the food will get heated up. See here, this is the same thing. Solar cooker, you can see the actual solar cooker. See, 4 pots she is going to keep and she is going to close it. Okay, close it, and this is the reflector which has to be open always. Clear? And this is one more new type where the rays, everything will concentrate at the center and the food will get cooked. Coming to the second thing is solar cell. How does the solar cell work? Solar cell work on the basis of photovoltaic cell. Photovoltaic cell, where you can see here, this is the photosensitive diode. Photosensitive diode, that means it will have a p junction, n junction. You will understand much better, but don't get into too much deep here. It is not required for you people. You will learn in POC science. So p type, n type, different materials. See, p type material is here and n type material is here, and inside there will be a depletion region, right? When both are joined, a depletion layer will be formed automatically because of construction. You can see here the top portion is connected to voltmeter and bottom portion is connected to voltmeter. Keep it at the sun. What will happen? The sunlight will come and fall here. What happens? It pulls the electrons. It pulls the electrons. It activates the electron to jump outside. That means it is connected here to a connector. So this will take all the electrons and it will start flowing inside the wire conductor. And if you keep a bulb here, the bulb starts glowing. Okay, it works on photovoltaic cell principle, and the photosensitive diode is used, which is made up of p and n material. Very very simple. See, this is a solar panel. Solar panel is here. A battery box is back side of the panel here, and here the battery box is kept here. Whenever the sunrise falls here, because of photovoltaic principle, what happens? Electricity is generated and it glows the bulb. A typical cell develops a voltage of 0.5 to 1 volt and can produce about 0.7 watt of electricity when exposed to sun. What is the power we are going to get? 0.7 wattage. Watts. 0.7 watts. Capital W means watts. What is the voltage? Potential difference? 0.5 to 1 volts. And but here also the installation cost is very high. The energy from the sea. Have you seen the sea or the ocean? Yes. And what is produced in the waves? What is produced in the ocean or the sea? The waves are produced. Have you seen the waves which is coming? You will enjoy taking bath there, swimming there, playing in the water, isn't it? So let us get into the science of it. Okay. We have low tide and high tide. What is a tide? What is a tide? We will see that. Due to the gravitational pull of mainly this moon on the spinning earth, the earth is rotating, the moon is also revolving around the earth, and what happens? The moon, there is attraction between the moon and earth. Okay, so the gravitational pull of mainly the moon on the spinning earth, the level of the water in the sea rises and falls. The rise of the water is called as high tide. The fall of the water is called as low tide. Okay, so using that high tide and low tide, we can form energy. What energy? Tidal energy. Okay, you can see here low tide means, see, high tide usually it goes up to 5 meters. That means the water level increase up to 5 meters. That is a high tide. Low tide will be normally usually at this level only. And you can see here in this process what is happening. A turbine is kept here. You can see two turbines are there. Okay, directly it is connected to generators, and in turn generates electricity, and it is given to grid, which comes to the factory, which comes to the house, everything. What happens? Closely observe. See, the water is entering here. Okay, and they start rotating, and suddenly this closes, and this will increase the height. And what happens suddenly if it is taken out? Again, the water flows from right side to left side. You can see here in this picture the tide coming in. When the tide is coming in here, high tide, this is low tide. Okay, it becomes high tide and this becomes low tide. See here, it rotates here, and it rotates the generator, and electricity is produced. This is tide coming in. And what happens again once it comes inside, and again it should come out. Okay, this becomes the high tide and this becomes the low tide. When it is coming opposite, it rotates the turbine in opposite direction, and we'll have some mechanism so that every time whether it is tide coming in or going out, we'll have an arrangement where always the generator will be rotating in the same direction, producing current. Okay, if it is a DC generator. If it is AC generator, it doesn't mind whether it rotates right side or left side. So because alternating current, positive will be there, negative will be there. That means it will rotate right side or left side. The turbine, it doesn't matter. So in both the condition, the current will be generated. Wave energy. Have you seen the wave energy? It's a beautiful phenomena. You can see here the waves is there. What is waves? The up and down motion of the water. You can see the water is going up, and again it is coming back. See here also, in this picture you are able to see it is going up, coming down, going up, coming down. Here also you can see going up in the form of wave. It is going, see, the wave is going here, it is passing here, right? The wave will flow from one place to other place. So it causes up and down motion. See here, so many things are connected here, where that up and down motion, you can see here the small thing is going up and down, up and down. This motion, it it generates the electricity. It generates the electricity. Ocean thermal energy. What is ocean thermal energy? It is the ocean, it is the sea, right? Ocean is collection of seas. Two or more seas join together and form a ocean. Thermal means heat. We know energy. Okay, ocean thermal energy. What is this, the ocean thermal energy? We can see here in this picture very clearly. You see here 0 meters. 0 meters means this is the surface of the ocean. Whatever you see, right, the surface, this is the surface, 0 meters. And if you go inside minus 1000 meters, that means 1 kilometer, or you still you have to go to 2 kilometer depth. If you go to 2 kilometer or 1 kilometer depth, what will be the temperature? The temperature will be 8 degree. And if you go up to 2000 degree, 2000 meters, that is 2 kilometers inside, it will be 5 degrees centigrade. Okay, so anywhere it should be, if you minus 28 by 8, see here 28 degree is there because of sun, because it is a layer, right? So sun falls directly here, and the top layer will become warm. Okay, so 28 degree inside is 8 degree. 28 minus 8, how much? 20 degree. See here, it should be having, for working of this machine, the temperature difference should be 20. And take here 25 degree minus 5 degree, 20 degree. Okay, it should be anywhere between 20 degree difference. Okay, the temperature difference. Hot water will be at higher temperature, cold water will be at lower temperature. So when you minus both, the difference should be 20 degree. You can see here the water is taken here. Okay, the water is taken here at 28 degree. The water is taken, it will be warm, and pump is given here, and it comes here. Okay, what happens? It is an evaporator here, and the cold water is coming here. From 5 degree it comes here, and the condenser will be here. And what happens here? Because of this, the warm water, it will get heated up. The working fluid will be here inside. It will be usually ammonia vapors. You can see here the The warm surface water is used to boil a volatile liquid. Volatile liquid means at low temperature it start melting. It start melting and it will become a steam kind of thing. It will become a gas. So evaporate is there. Because of the temperature difference, what happens? It evaporates and it creates a pressure. It becomes a gas and it rotates the turbine. And you can see here the generator is here and turbines rotates the generator, electricity is produced. And again the working fluid, that ammonia will come here, it will get cooled. Because of this cool water it comes out and again the same water is left inside the ocean. See here the cool water is coming here and it cools the ammonia and again it comes back. Why it is 8 degrees centigrade? Because it is picking up the heat of the ammonia, that's why the temperature is more 8 degree. Again here the 28 degree it is coming here because cold water everything is coming here and going. Okay, and the ammonia is coming at cold temperature here and it is coming here and it is left. Why? Because the 3 degree is picked up by the ammonia. The 3 degree rise in temperature will make the ammonia into vapor form or a liquid form to run the turbine and generator. This is ocean thermal energy. Just remember this picture and you can write on your own. Only difference is from the temperature difference should be 20 degrees centigrade. Geothermal energy. What is geo? The meaning of geo is earth. Thermal means temperature. That means geothermal means that heat in the earth is taken. You can just see here this picture, the first picture you can see. Okay, this is the production well, this side, and this is the injection well. The cool water is injected back to the well. If you see on the earth, there are a lot of hot spots. Lot of hot spots. What is that hot spot? See, the molten rock formed in the deeper hot regions of Earth crust are pushed upward and trapped in certain regions called hot spots, that molten rocks. When underground water comes in contact with the hot spot, steam is generated. Sometimes hot water from that region find outlets at the surface. It comes out of the earth and we can see that hot water will be sprinkling outside the earth and it will be very, very, very hot to touch, very, very hot to touch. One place is Manikaran. If you go there you can just touch the water and it will be boiling. In there they offer the food for the god. How? They'll take a cloth, in the cloth, on the cloth surface they put the rice and they keep it in the hot spring. What will happen? The the rice the rice will become cooked. Okay, all the rice grains will get cooked and it will become a rice to eat. So that is called as a hotspot. See here how the working will happen. From the inside the earth, the steam, that water, the very hot water and the steam is pumped. We have to keep a pump here and start pumping here. And that hot steam, because since already it is at the steam condition, it will be under high pressure. So high pressure steam is left here. You can see the 4 turbines are kept here. What happens? 4 turbines, all the 4 turbines will rotate and it rotates a generator here. The generator is rotated and once the generator is rotated it produces electricity which is given to the electric grid or the poles where we get the electricity from the pole. And what will happen to the water which is coming here, right? The steam is converted because it becomes cool and the steam is converted into water and this water comes here and we are going to keep a condenser here where it cools the water and that cool water again it is left back to the production well. You can see here, you can see this picture. I'll show you beautifully, it is explained here. See here the red pipe is hot water is coming here and is going to the flush tank here. And you can see here the once the water comes the steam is, it picks up the steam, all the steam under pressure, and the pressure it is left to the turbine and the turbine rotates and electricity is generated. See here the hot thing is there and this is the cool thing. It all the steam is collected here with pressure, and that is left onto the turbine. Turbine rotates at very high speed. That's how the thermal geoenergy is produced. See, there are a number of power plants based on geothermal energy operational in New Zealand and United States of America, that is US. So many geothermal power plants are established or installed in those areas. Coming to our nuclear energy. How is nuclear energy produced? Because of nuclear fission. You can see here nuclear fission. What is nuclear fission? What is nuclear fusion? Fusion means fusing. That means joining is called as fusion. What is fission? It is getting separated. A metal is there. That means it is as good as breaking and making into powder. That means fission means the separation of the atoms. The separation of the atoms is called as nuclear fission. The nucleus of a heavy atom such as uranium, plutonium or thorium when bombarded, that means it is hit. Bombarded means hit. When bombarded with low energy neutrons can split apart into lighter nuclei. That means it is separating the nuclei. Okay, it becomes smaller. The big ball will become into smaller balls. When this is done, a tremendous amount of energy is released. When it splits, when it separates, what will happen? High amount of energy is released. Okay, so that high amount of energy is used in, you can see here, this is the nuclear power plant. You can see this picture. Nuclear power plant will be very big. Okay, and you can see small cars here. Okay, and you can see the uh, different equipments placed here, the building, the nuclear reactor. See, this is a nuclear reactor. It produces a lot of heat, and lot of heat has to be it has to be exhausted. Okay, and the condenser is placed, and you can see a lot of smoke coming here. This is a miniature version of nuclear power plant, and you can see this picture. It clearly explains. See, this is the nuclear reactor. This is called as a nuclear reactor. This is called as reactor vessel, and these are control rods. Okay, control rod means if you place the control rod inside, that means it contains the heavy metals, that is uranium, plutonium or thorium. Once it gets inside, the bombardment will be more, and it produces more heat. The more heat is released, that heat is utilized. You can see here the heat is coming here and coming here. There is some liquid inside which will come here, and the cold water, you can see here the water is coming from this side and getting here. While going inside this pipe is placed inside, what will happen? It will pick up the heat. And it becomes steam. You can see here the steam again comes and hits the turbine. The turbine will rotate the generator. Generator produces the electricity. You can see here it is producing the electricity, and the electricity goes and gives the light to the building. You can see here the electricity is generated, is going and giving the light to the building. Or it might be houses, it might be mall, it might be factories, it might be big industries, it might be anything. So that's how the nuclear energy is being produced. One more important thing here we need to note is improper nuclear waste storage and disposal unit result in environmental contamination. See the control rods, because since this is a nuclear fission process, lot of emissions will happen. Okay, radiations will happen, and it will contaminate all the parts which has been used. Once the parts has been used and there is no use of those parts, we cannot just throw it on the earth surface. What we have to do, we have to store it, and we have to hand over it to government in a very neat manner where the radiation should not happen. If leak happens, then there will be radiation. So that's why improper nuclear waste storage and disposable result in environmental condition contamination. Further, there is a risk of accidental leakage of nuclear radiation. So this we need to keep it. Save environment, save energy. We can see the environmental consequences. What is environmental consequences? That means for producing so many products we are converting from the raw material, which we get the raw material from the earth. So we take the raw material from the earth and convert it into product. During those process, during conversion of raw material into the product, what happens? Lot of process is involved. During those process, lot of gases emits, lot of heat is given to the environment, a lot of damage will happen to the environment. Based on that, okay, we need to be very careful and we need to save our environment. And how long will an energy source last us? Because as we seen, the coal, the petrol, diesel, turpentine, everything is a petroleum product, and it will become depleted. That means it will become empty in coming years. Why? Because for a fossil fuel takes millions of years to form the crude oil. From the crude oil we get the petrol, diesel, everything, isn't it? So the fossil fuels takes a lot of time to generate these kind of things, and once we use it from the earth's crust, what will happen? It becomes empty. So that's why we are going for a renewable sources of energy, that is solar energy, batteries, wind energy, ocean energy, tidal energy, wave energy, geothermal energy. So all those kind of energies we are slowly shifting, because the conventional energy sources will last sooner. Clear? End of this chapter. If you people have any clarifications or any doubts on any of the topics, please reach out to me. I'd be most happier and happiest to serve you people in clearing the doubts. Thank you so much for being with me for such a long time. All the best. Thank you so much.